I'm studying microplastics presence in river waters. This is a collaborative research. We are studying on Brahmaputra river. So we have counterparts from India, counterparts from Bangladesh and Bhutan. So I'm studying rivers of Bhutan that joins with Brahmaputra. So that's why I have two locations, mostly in southern part of Bhutan, because it joins with multiple rivers of Bhutan, and these are the major rivers. So you have Tulsa River in south, Manas River in center, and one is Harachu, because this is a river where community fishery is allowed in Bhutan. So I also want to study how much of plastic or microplastic is present in water system, in fish, and because the community and also we consume fish from that stream, whether it gets into our food system or not.
Okay.
So that is the focus of the research. And here, because we can identify plastic at its scale of what is its length, what type of plastic is not feasible in Bhutan. So the plan is to send it out of Bhutan in either India or Bangladesh. That would take a little bit of time, but given few months I have, we will be able to identify plastic, count what scale, what color it is in different samples: sediment, fish, water. Solution is basically we go back to what we already are aiming at: proper waste management, proper segregation, education awareness, which it's still not it's poorly done actually, waste management, because if you go around, littering is everywhere. And how is this plastic getting into rivers is because it's not managed well, or people are not aware of their actions. So that is basically what it is. This field is relatively new, and there are very less papers explored, especially in fresh waters. There are tons of papers in microplastic contamination in oceans and fish, etc., but quite less. There are a couple of number of papers coming up for Asia and for fresh waters in Himalayan region. So this could be a few of the papers that we can contribute to as a research objective. So first is to evidently show plastic is getting into rivers and food systems through fish. And after that, at least awareness can be done at this point. But to a large extent, to stop plastic pollution, it's going to be a very tasking and a huge step that we are not able to do. So we have brought river sediment samples from various locations in Bhutan. So once we bring the sediment, we have to dry it in the oven for 20 hours at 40 degrees. 40 degrees Celsius. This is Asia, so it's all Celsius. And after that, we take out the dried sample and we mix it with Calvin solution. That is to separate the particles that are stuck together. So when we separate it, we can either use magnets or we can manually do it like we're doing here. So we do it for 1 hour. So that's what we have done so far. Now we have to, what is the step that we always follow? Labeling. Now we are making Calgon solution. Calgon solution, what it does is, sediments will be clumped because river base because of pressure or even while so many things are moving around, clumped and at our level we see it as free, but microscopic level particles are very squished together or stuck together. So this Calgon solution, it helps to disperse. Connecting microplastics, so if it is attached, this will help it to detach from the sample. So that's why we're making this. We take 5.5 gram and mix it in this distilled water. So use this dry spatula. We will measure it here. Okay, so let's turn this on. 5.5 gram. to mix daily, but this should be washed with distilled water. So get one of this. Direct matsu because heavy with being fracture, you tilt this side and this side. Okay, now place it on magnetic stirrer. This can give, it has magnets, so it helps in stirring the sample solution. It also had heat, so you can increase or control temperature. So you can heat your sample.
So what is the average temperature that you use?
For this sample, we just need to mix it. So there is no temperature requirement for this solution. But for other solution, where we are mixing with plastic, the organic matter, so digest we need to maintain between 50 to 60. So now there are two buttons here. One is for magnet on Waymo. So we turn one on. This looks like it's for heat. We turn this on. It will start moving. So we are not going to add temperature. If it is not mixing, then we'll increase the temperature. So let it mix, and when our solution is ready, we will proceed with mixing.
How long does it take to mix the solution?
Mix the solution? It depends. Sometimes it can go in 15 minutes, but for now, it's not moving enough to break those clumps. So we might have to increase the intensity of magnet. Anyway, if you can see the difference, now it's moving fast. Now it's moving everything. So it depends. Sometimes we can also use the spatula and do it manually. We'll use that to break those lumps. The intensity is way too big, but the magnet is so small, its own force key, it starts to move around, and then we might crack them. So you have to be very careful with how, at what intensity you're using the magnet. So this has now become our calgon solution. No? So this is our stock. We can use it multiple times. I'll show you the dry samples. This is our hot air oven. And here are all my samples that we placed yesterday.
It's sand.
Oh, these are river sediments.
Okay.
So we have sandy river. Okay, now we'll remove one of the sediment. So bagina ku Otjánbird. This is set at 40 degrees for the sample. So current, because I was opening and closing, it has become 30 degrees. But it's set at 40. Timer, it's kept for 21 hours since yesterday. So now it has already completed 21 hours. And that's the fan and flap key speed. So we are concerned with these two for my sample. So the sample is dry. This is from Harachu, first location, and this is the monsoon sampling. This is a river sediment.
Sample number 2?
Second time.
2 replication.
Yes. No. This is the first location. And this 2 means I collected this during the monsoon period.
Okay.
1 would be for my winter time. This is monsoon. Sample gets moved from one to another, don't forget to label it. In one data, you will shift between 4 to 5 different containers per box. So always remember to label. So we will keep on mixing it for 1 hour. Mix it. Otherwise, we will not be able to separate the particles. So as the heat used with the box, so I'm going to increase the heat a little bit. So that sample the temperature. So we'll keep it until 50. So we are not going any more beyond 65. And though in my experiment and field work here, lab nalo, I'm sticking to 50 or 60 because 70 it's going to damage the plastic.
Degrees Celsius?
Oh. But I shove it. Okay, and the sample B. This is here. Okay. Nasibiyodulu maoligidi astantikiyodulu. So now what we will do is using a spatula to we thoroughly rinse it. And all surface should be rinsed because that's a calcium solution used so that has dispersed all the particles. Now we're washing it down. So microplastic bendigi, it will go past through this sieve, and magidi, we have a smaller sieve, it will hold it. The magi will become our final sample. And we rinse it thoroughly, care and disturb baby, so that our sample is washed down. The sample we have to vigorously toe. Okay, so you finish those two as well, bits of two. But at the same time, be mindful over reload the water over and overflow, and your sample plastic it might float out. So over choose time you try to just disturb it a little bit, and don't take it up and tension. Okay, so when it's slow bit, you have to take your time. When you're finished. We will transfer the sample in this beaker. So before that, we need to label it. So we will try it and label with marker content. Vegetable and the organic matter acid then it will digest.
it is 400, we'll make it 600.
So now this sample, we will put it in density separator. That will it will settle in, so we will not close it. Now as there is a thin random, then we will use. But we will just close it. Now, so there is no contamination. And we will tie it to a pole where it is not moved. So in our lab we have tape. So we tie it to a table. So all the organic matters have been digested. This is a density separator where sediments, heavy sediments, including soil particles and rock remains Sieving, those will settle down. Plastics, because it will be lighter, it will float up. So this is how density-based separation will happen. So here this knob moves. So right now it's open. So, any twist below. Now it gets locked here. So now we will remove whatever sediments we have or sample we have from the upper part, and this one gets blocked because of this. Sometimes this pipe can be of bigger size, circumference, and at least 1 liter the water shown, because your final solution after the second process 1 liter the chomba, a little less than 1 liter. So you need 1 liter capacity. Where this should be in the center block, because you want most of it to be in the center. Now we will remove the half portion. Now we are collecting the top sediment. Okay. So now this will undergo filtration. And here, actually floating microplastics. So Anidhi, we have to cover with aluminum foil. Here we have filtration, vacuum filtration. So if you come closer, I'll show you. So this here is filter paper where our sample has been filtered. So the residue is over here. This is the residue, but our microplastics has been filtered and it is there in this filter paper. So what we will do is, I've already filtered one batch. Okay, now I'll remove this carefully and place it here. And now I'll place next filter paper. So we have Wattman filter paper grade 1, because that is what we need to use for sampling microplastics. So we take one, we have a large microplastic, so we cut out a small part and we place it here, and then we close it with the help of this clamp and it holds it. Then we pour our sample in here, and after filtering all of this, all the samples with microplastics in the filter paper will be kept in desiccator. So this is the desiccator. If you want to come on this side. So we have all the filtered samples here to be dried, and after it has dried, this samples looks like it's all dry now. We will watch it under microscope for the presence of microplastics.
Okay.
Which I will show you in a bit. This absorbs moisture. So if it has absorbed a lot of moisture and reached its capacity, it will change to blue. And then we have to take it to oven and dry it again. So right now it's pink, which means it can still absorb moisture. So we have samples here. So this filter paper, we need to cut it to the size of the filtration. What do we call this?
Filter.
Filter. Mouthpiece. Surface. Whatever. So for that, I'm going to cut out small circles that will fit in here. So I would fold the paper and cut out a circle. Almost perfect circle. And from here we take one. And we place it here, and then we place the holder from the top and we put the clamp so it holds. Now the sample goes in. Close it back. Now if we keep it like this, it will take maybe half an hour or a little bit more, because it works on gravity, so droplet by droplet. To make it faster, we have this motor. We switch it on and it sucks the air from here, the air that is flowing from here. So with the help of that, it makes the process a little bit faster, but it still takes almost 15 or 20 minutes. So we wait until it filters, then we put another one and it goes on and on.